The next thing we'll look at is a little bit different. We're going to look at the importance of attributing these different portfolios to what we know to be priced factors. And so what I want to do is I want to look at measuring the excess return for a portfolio of small cap stocks and the problems that come from not realizing that they're small cap stocks and measuring it against the S&P 500, which is a large cap index. And so this is an example of some work I was doing a number of years ago for a nonprofit endowment. I was on the investment advisory committee, and every quarter a group of us would get together and we would meet with the manager of the endowment. The manager would report the results, and so this is a story about what happened back then. And so the question is, did the manager beat the market? And we know that small earns more than big, value earns more than growth, of course not in every period. Now, why is this the case? Well, we're not sure. Maybe small and value are riskier, or maybe people just don't pay attention and to small and they herd growth, who knows? But what we have to do is really look at the performance attribution and really try to determine, was there risk-adjusted excess return in this portfolio as the manager was claiming. So I'm going to look at first a quick PowerPoint to show you some of the data that we were presented, and then I'm going to go to a spreadsheet where we do some analysis. And this is a document that we were sent on the Investment Advisory Committee as part of our quarterly review. And you can see this is just a wealth index chart starting at $100. This gives us the value of $100 going forward through 2013, which is when this was presented to us. And the brown line is the active portfolio, and the yellow line is the S&P 500. And the manager presented this and said, well, look what a great job I'm doing. And I'm looking at this and I'm thinking, this guy's just rocking a bunch of beta. There is exactly the same sort of movements as the market, but it just seems riskier than the market. So let's see what's going on. So what I did was I downloaded a bunch of, I said, send me your data, and I put all the data into a spreadsheet, their monthly returns into a spreadsheet, and then I compared it to the S&P 500, and I got the same thing. So I replicated the chart, so that was good. And I'm going to refer to the actively managed portfolio as active, and the indices are passive. And remember that the Standard & Poor's Company runs 3 different broad market indices. It runs an S&P 500 for large cap, it runs an S&P 400 for mid, and an S&P 600 for small. And so here is this portfolio versus the S&P 500. This is the same chart that they sent us, and I did $1 and they did 100, but same thing. And then I ran it against the S&P 400 mid cap, and then I ran it against the S&P 600 small cap, and this is pretty similar. And so we asked the manager, are you buying small stocks? And the manager said, yes, I am buying small stocks. I believe that I can find, it's easier for me to find mispriced securities amongst the universe of small stocks than it is for me to find mispriced securities amongst the universe of large stocks. And that's a perfectly reasonable statement, but it also means that the alternative investment shouldn't be the S&P 500 as a benchmark. It should be the S&P 600 as a benchmark, because it might be the case that you're not just picking good small stocks, that all small stocks are good. And so that's what we need to measure. So let's go to a spreadsheet and we'll look at some analysis. And so here's the data in the spreadsheet, and what I have are monthly returns from September 2000 through December 2012, which is when this analysis ended. And I've calculated some statistics. I've calculated the annualized average return for the 4 different portfolios. Remember, it's the active, small, mid, and small cap stocks. Here are standard deviations. Here are total holding period returns and annualized holding period returns, which are the geo means, and here's the monthly data. In addition, I have the wealth indices over here. And remember, what we're doing is we're trying to find evidence, or we're just trying to examine whether or not this manager earned risk-adjusted excess returns. Did this manager beat the market, or did this manager just buy small stocks and the market went up? And so if it is the case that this manager has said that the plan was to pick really, really good small stocks, and then let's compare to see whether the manager picks good small stocks or just picked average small stocks. Is there an alpha when we compare to small stocks? And so here are the wealth indices again. Here's the active versus the S&P 500. Here's the 400. There's the 600. That's what sort of got me going on this. Here's all of them together. And now I'm going to run regressions. And I'm going to do them slightly differently. But the regressions that I'm going to run is I'm going to run the active portfolio on the S&P 500. I'm going to run the active portfolio on the S&P 600. And then I'm going to run the, well, let's just do those two first. So this is what the manager essentially was trying to get us to buy into, was that the R squared, which is 84.66%, the intercept is positive, it's 0.61% per month. On an annualized basis, this is 7.37% per year, and it is statistically significantly different from zero. And this portfolio has a beta of 1.04. And I just pulled those numbers up here, and here's the annual alpha and the p-value that we can use to determine whether or not this annual alpha is significant. Well, then I did it again on the S&P 600. And here I can see that the intercept, it's no longer statistically significantly different from zero. Instead of having a 7.37% annualized alpha, I have a 1.5% annualized alpha. And no, it's not statistically significantly different from zero. And just to, I don't know, piss them off a bit, I ran the S&P 600 on the S&P 500 and put everything in a table here. And so let's just take a quick look at the table. This is the active on the S&P 500. Here's the beta, it's significant. Here's the alpha, it's significant. But if I run the active on the S&P 600, I can see that it is actually, the alpha is no longer statistically significantly different from zero. The alpha goes away. And just to check, I ran the S&P 600 on the S&P 500 and got almost the identical results as the active on the S&P 500. And so here's the idea. Let's assume that I have something that looks like a normal distribution. And oops, I didn't want it to do that. Normal distribution. And I have a mean in the middle. And I have one standard deviation to the left. If I were to go one standard deviation to the left and the right, then there would be 68% in the middle and then 32 on the tails, which means 16 in each tail. I have something slightly different here. What I'm talking about is going to be, whoops, let's go back to the pen. What I'm talking about here, this is going to be a estimate of a average deviation. This is how much I expect the managed portfolio to beat the benchmark by. Here is one essentially tracking error to the left, and the idea is that there's still 16% because the average deviation is equal to 7.40%, and the tracking error is equal to 7.37%, which means that the ratio of these is 1.00. The information ratio, I might conclude that there is an 84% chance that this manager will beat this benchmark index in any year. That's how I would interpret this extremely high information ratio. So I'm back to the spreadsheet, comparing the different annualized deviations, annualized tracking errors, and annualized information ratios. And we just looked at this and we said this has an annualized information ratio of 1, which means my annualized average deviation is 1 tracking error from 0. So therefore there's an 84% chance. But see, when I move to the mid cap, I have an information ratio that is significantly smaller. And then finally, when I move to small cap, you can see that my annualized average deviation is very, very small, only 0.2%. My tracking error is large, and my information ratio goes to 0. We've already established that the S&P 600 is the correct benchmark. We can now conclude that there's roughly a 50% chance of this manager beating the S&P 600 or not beating the S&P 600. Okay, so back to the notes to summarize the results. And remember, the whole point of this is the importance of choosing the correct index, the correct benchmark index with which to assess whether or not there is risk-adjusted excess return, whether or not the manager actually beat the market. And so when the manager chose the S&P 500, when we looked at the regression results, we had a positive alpha. It was statistically significant. But when we compared it to the S&P 600, we saw that the alpha was, well, much, much smaller and not statistically significantly different from zero. And in fact, the S&P 600 index on the S&P 500 index seemed to pretty much match this manager's performance. So a positive and significant alpha indicates risk-adjusted excess return, but you have to calculate this using the correct benchmark if you want to assess manager skill, right? Earning more than you should have. And so when the active managed fund is compared to the S&P 500, which is the wrong index, because the active fund is made up of small stocks, and the S&P 500 is made up of large stocks, and we know small stocks earn more than large stocks. They're also riskier. And so we have this very large annualized alpha and p-value, but when we compare it to the correct fund, we see that it is not statistically significantly different than zero. And then the tracking error, when we compare the tracking error and information ratio relative to the S&P 500 relative to the S&P 600, the annualized average deviation of the active fund compared to the S&P 500 is 7.4%, which is super high, as is this information ratio, because the tracking error is relatively low. And so we interpret this as the number of tracking errors to go from the average deviation to zero. And so we can infer that the probability of the active fund beating the benchmark index is roughly 84%. But this is not likely due to manager skill. It's likely due to picking riskier stocks. And so we want to compare it to a like benchmark. We see that there's only a 2 basis point annualized average deviation compared to the S&P 600. And this is very small. The tracking error is very, very large, and so therefore the information ratio is effectively zero. And so we'd say that this manager has a 50-50 chance of beating this benchmark. A better way to identify style, of course, is to run the Fama French factors as opposed to just looking at the graph, which is what I ended up doing. And so you just regress this on small minus big and high minus low in order to assess the betas. Let's come back and we'll talk about what I should include and what I shouldn't include in my regression models, what factors might be included and what factors should not be included.